so now we're going to find a formula for r sub n and compute the area under the graph as a limit. So we're given the function f of x is equal to 6x squared minus 4, and then our interval is from 2 to 5, so a is equal to 2 and b is equal to 5. Alright, so let's start writing our formula for our right endpoint approximation. So r sub n is equal to delta x, and then as j goes from 1 up to n, okay, and then we have f of a plus j times delta x. Okay, so first of all, what is delta x? Delta x is going to equal the length of our entire interval divided by the number of subintervals, so that's going to give us 3 over n. Okay, and we don't know what n is, so we're just going to leave it as such. Okay, so we do know that a equals 2, so we'll be able to plug that in a little bit. So delta x is equal to 3 over n, and then we have that multiplied times the sum from j equals 1 up to n of f of a, which is a 2, plus j times that delta x, which is 3 over n. Okay, so here we see that because our a is not 0, we can't just cross out that 2, right? So we have to plug this entire thing that I just circled into our function f of x. Okay, so now we'll get something that looks like r sub n is equal to 3 over n, and then the sum of from j equals 1 up to n of, and now we have a 6 times x, and in for x we're plugging in 2 plus j times 3 over n. Then we're going to square that entire thing minus 4. Okay? Alright, so now let's see what we get. So r sub n is going to equal a 3 over n, and then we have the sum from j equals 1 up to n of 6 times, and then from here we get 2 squared, so that's a 4. And then if we square this last term, we get plus 9j squared over n squared. And then if we multiply those two terms and we double it, then we get 12j over n, okay? And then minus 4. Alright, so now let's simplify a little bit and we'll continue on the next slide. Okay, so here's where we left off. We had r sub n is equal to 3 over n, that's just sitting outside. Then we have the sum as j goes from 1 up to n of a 6 times, and then 4 plus 9j squared over n squared plus 12j over n, and then that minus 4 is on the outside. Okay, so if we continue simplifying, we have 3 over n is going to be times that j equals 1 up to n, and then we have a 24 if we're distributing the 6, right? So plus 54j squared over n squared, and then plus, and 16 times 12 is a 72, so we have 72j over n and minus a 4. Okay, so now if we simplify even further, we get r sub n is equal to 3 over n. That one's just going to hang out there in front for a while. And that's going to be j equals 1 up to n, and then 24 minus 4 is a 20, so we can simplify that part. And then we have 54j squared over n squared plus 72j over n. Okay, so here's where we can distribute that guy in. So we can basically just take both the 3 over n and this sum thing, and we're going to apply it to each of the terms we see here. Okay, so what this would look like is r sub n is equal to 3 over n, and then we can take that 20, right? And since that's just a constant, well, I'll just keep it there, okay? So if we apply it just to the 20, we have this, and then we're going to add that to 3 over n times the sum of, from j equals 1 up to n, of 54j squared over n squared. Okay, and then finally we have the same thing. We're just going to distribute that guy in. So we have something like this, and then that's 72j over n. Okay, so now what we can do is actually take out any constants. We can factor out any constants from each of these terms here. So what we can get is r sub n is equal to, and then we have 60 over n, and then we have the sum of from j equals 1 up to n of 1, and then plus we have 3 over n, so 54 times 3 is now a 162, so 162 over n cubed, because we have 3 of those on the bottom now, and then we have our sum of from 1 to n of j squared. Okay, and then over here we have 72 times 3, so that turns out to be 216, and then we have n squared on the bottom. okay, because we have 2 of those left there. All right, so then we have j goes from 1 to n of just a single j, okay? So I'll rewrite this last line on the next slide so we can continue on. So now we have r sub n is equal to 60 over an n, okay? And then we had this guy just sitting there up to n, and then an n, or not n, sorry, and then a 1 here, a 1, okay? And then this is being added to a, not a 54, but a 162 over n to the third, and then we had j goes from 1 up to n for j, and then we have a squared one here, and then this is a j, okay? And then lastly, for this term, we had 216 over n squared, and then the sum from j equals 1 to n of just a single j, so j to the 1 power. Okay, so this here, we can actually simplify these sum things. So we have 60 over n, and this thing, because it's just a 1, that means that we have 1 plus 1 plus 1 plus 1, all the way up to n many times. So that just means we have n many 1s. All right, so that'll be an n plus 162 over n to the third, and we replace this guy. Remember, this is the power sums. We're going to keep those in mind, remember? So this is going to be an n to the third over 3 plus n squared over 2 plus an n over 6, okay? And for this last one, we have 216 over n squared, and in for the j1, all we have to plug in is an n squared over 2 plus an n over 2. Okay, so now we're going to simplify this out, and we get that these ones cancel, and we get r sub n is equal to 60, and then we have plus, okay, so then we have plus our next term, which is these ones cancel out, and we get 162 over 3, which that's a 54. And then we have plus, and 162 over 2 is an 81. So then we have 81, and we have 1 n left on the bottom when we distribute that one. And the last one is a 162 over 6, so that's a 27 over n squared. Okay, and the next term, when we do these ones, we just get 216 over 2, so that would be a 108. Okay, and that last term is going to be, again, a 216 over 2, so this is a 1 over 8, but now we have an n left on the bottom. Okay, so now let's combine all of the constants like we can. Okay, and then we'll combine the n terms as the terms over n as well. So r sub n is going to end up being 60 plus 54, that's 114, plus 108, so that's going to turn out to be a 222. Okay, and then we get 81 plus 108. That's going to be 189 over n, and then that 27 is just by itself over an n squared. Okay, so this, we've finally made it, is our r sub n. That's our right endpoint, our nth right endpoint approximation. So now what we have to do from there, yes, there's more. There's always more. But anyways, so what we're going to do is express the area under our curve as the limit of that approximation as n goes to infinity. So our area is going to be limit as n goes to infinity of r sub n. So we're just going to plug in what we had. So area is going to equal the limit as n goes to infinity of, and we'll plug that in, 222 plus 189 over n plus 27 over n squared. Okay? So when we plug that in, we just get 222 plus 189 over infinity plus 27 over infinity squared. So both of these terms, the final ones, those are going to go to 0. So our final answer is going to be that the area is equal to, or about equal to, 222. Sorry about that. Okay, so yeah, that's it. That is our final destination. Okay, so that wraps it up for this video, this practice problems video on approximating and computing area. I hope that helps, and happy studying.